Hello, and welcome to my channel, Reading Little Blue Books Out Loud. This is a little blue book. This one just happens to be Little Blue Book number 409, titled Great Men of Science, written by Hereward Carrington, PhD. Now, this is Great Men of Science according to 1924. The copyright of this is 1924. This is part 3, and we left off at the top of page 26, and we are starting the chapter on physicists. The history of physics is lost in the dim obscurity of the past. Archimedes, Ctesias, Hero may be mentioned as typical names of antiquity. Aristotle wrote upon the subject, though the Greeks added but little to practical science. Not until we come to Galileo do we find a name worthy of mention as a physicist of the first rank. From his time onward, however, we find an ever-increasing number of great men devoting their lives and energies to the furtherance of physical science in all its branches. Torricelli, the pupil of Galileo, constructed the first barometer. Fahrenheit, soon after, devised the thermometer, which bears his name, and half a century later, Celsius devised the centigrade scale. Gilbert, physician to Queen Elizabeth, conducted some of the earliest experiments in magnetism. Foucault carried on his famous experiments with a pendulum, which led to the invention of the pendulum clock by Huygens. Roemer first computed the velocity of light, though it was 50 years before any attention was paid to his epoch-making discovery. Thomas Young drew attention to the phenomenon of the interference of light, but again no attention whatever was paid to his discoveries for many years. Fraunhofer, who made the first perfect lenses for the telescope, drew attention in the dark lines observed in the visible spectrum. They were finally explained by Kirchhoff, thus giving rise to the modern work in spectrum analysis. Galvani, in 1780, accidentally discovered galvanism. Since named after him, Alexander Voltai, in 1800, first created an electric current by means of metals and sulfuric acid, the first voltaic pile, or battery. Ampere was the first to measure the intensity of electric current. The terms ever since employed volt, ampere, etc. are of course in honor of these men. We now come to Faraday, one of the greatest of all experimenters. He it was who discovered the electromagnetic induction. He first gave the name lines of magnetic force, which have since become so famous. Faraday obtained the first continuous electric current by cutting the lines of magnetic force. The first crude generator, our science of electricity, has largely developed from these initial experiments of Faraday's. Tyndall was another great experimentalist of this period. His Fragments of Science is a classical book, while his work on heat as a mode of motion was also a turning point in the history of physics. Tyndall's achievements were so varied that it would be impossible even to begin to enumerate them here. Argot, Ruhmkorff, Page, C.F. Varley, Grove, Wheatstone, Oersted, Joseph Henry, Morse Daniel. These are but a few of the names which shine out in connection with the development of the science of electricity. Geyser devised the tubes which bear his name. Peter Cooper Hewitt invented the mercury vapor lamp, now so extensively employed. Edison perfected the electric light, while Alexander Graham Bell completed work upon the telephone, or probably telegraph. Nope, telephone. The ingenious mathematical work of Clerk Maxwell, followed by the practical experiments undertaken by Hertz and Lodge upon electric waves, rendered possible the perfection of wireless telegraphy by Marconi. Nikola Tesla had meanwhile carried out his remarkable experiments upon high-frequency currents. Branly devised his courier, employed for some time in wireless transmission of messages. D'Arsonval conducted a number of important researches upon electricity and devised the galvanometer, which bears his name. Steinmetz developed the science of electricity in many practical directions. Lee de Forest perfected the Audubon, thereby greatly advancing the possibilities of radio. Sir William Crookes began his renowned experiments in high vacuum tubes in 1879, which were followed up by those of J.J. Thomson in 1883. Hertz continued these, and in 1893 showed his assistant Leonard the rays penetrating a sheet of aluminum foil within the tube. Leonard attempted to pass these cathode rays through a quartz window in the tube, but failed. He succeeded, however, with an aluminum window. The next year, 1895, Professor W.K. Roentgen, who was following up these experiments when he made his great discovery of the X-rays. The properties of radium began to be subject. Let's try that again. The properties of radium began to be the subject of intense study soon after this, and Professor Rutherford investigated the three kinds of rays emitted. In 1902, Rutherford and Soddy advanced the theory of atomic disintegration and predicted that helium was being formed as a product of changes in the radio elements. The next year, Ramsay and Soddy, when investigating the spectrum of radium emanation, discovered some bright lines appearing. They found these to be due to helium, which was being evolved directly from radium. Helium has since then played a more and more important part in chemistry and the theory of the atom, and this gas, which was at first thought to be present only in the sun, is now manufactured in large quantities so that airships are filled with it instead of hydrogen. And on the other hand, helium has played an important part in recent theories as to the ultimate structure of the atom. Sir Oliver Lodge is today recognized as probably the leading authority on the ether of space, having studied it intensively. His book, The Ether of Space, is a valuable contribution to the subject. More and more attention has been paid to this subject of late, owing to the theory of relativity, which has virtually challenged its existence. Inasmuch as light plays such an important part in the relativity theory, a brief summary of the history of light investigations may be of value. In 1621, Snell, a Dutch professor of mathematics, discovered the laws of refraction. In 1665, Grimaldi discovered the phenomena of diffraction. In 1666, Newton decomposed white light into the colored spectrum. In 1670, Bartholomæus discovered the double refraction due to light passing through a crystal of Iceland spar. In 1672, Hooke, London, suggested that light was a transverse wave motion. In 1676, Romer, Denmark, discovered the velocity of light. In 1678, Huygens, from Holland, suggested the first clear ideas of a wave theory of light. He was able to explain refraction, but other phenomena did not seem to fit in. In 1802, Wollaston, an English chemist, discovered the dark lines in the solar spectrum. In 1803, Young, from London, published his renowned wave theory of light. In 1814, Fresnel, from France, reintroduced Hooke's idea that the waves of light were transverse and not longitudinal waves. He was thus able to explain the phenomena for polarization. In 1814, Fraunhofer from Germany used a telescope to view the solar spectrum and was able to map out hundreds of dark lines, all having fixed positions in the spectra. He found that different stars had different spectra, and that the spectrum lines were due to the light emitted by the stars. In 1845, Faraday discovered a direct connection between light and magnetism. In 1860, Kirchhoff, from Germany, discovered the meaning of the lines in the spectrum first noted by Wolfenstein in 1802, and investigated by Fraunhofer in 1814. In 1873, Clerk Maxwell published his remarkable theory of the electromagnetic waves of light. In 1880, H. A. Lorentz from Holland suggested that light was due to particles revolving round atoms. In 1896, Zeeman from Holland detected the revolving electrons by means of a spectroscope, a sodium flame, and a powerful electromagnet. He also discovered that a single line in the spectrum of sodium was made to alter its otherwise fixed position when a strong magnetic force was applied to the sodium flame. This important discovery led to others which have had a profound bearing upon modern physical theories. Einstein suggested the bending of light rays because of the pull of gravity, this being one of the proofs of his theory. Only recently, Dr. St. John, solar physicist of the Mount Wilson Observatory, has stated that he has obtained the third necessary proof of the Einstein theory, viz. The gravitational displacement of solar spectrum lines. The theory of relativity is based partly upon the famous Michelson-Morley experiment, which showed that there was no friction or drag upon the ether. This classical experiment has since been repeated with the same results. Julie Meyer, Becquerel, Riley, Sullivanus, P. Thompson, Joly are all great names associated with the development of physical science during the past century. Lord Kelvin's name likewise occupies a very front-rank position. Sir J. J. Thomson is largely responsible for the electrical theory of matter, which has assumed ever greater importance in modern physical theories. A young and prominent physicist, Moseley, was the first to count the number of electrons in the atom. He was killed by a Turkish bullet during the Gallipoli campaign, when only 27 years of age. Aston of Cambridge, England, has developed the theory of isotopes, which has assumed such importance in recent atomic theories. In America, Robert A. Milken, Trowbridge, Wood, Lewis, Langmuir, Pupin, and Gibbs deserve special mention. Next chapter, Biologists. Make sure I didn't skip a page here. Nope. Page 32. Biologists. The greatest student of living organisms in antiquity was undoubtedly Galen, 130 to 200 AD. He gathered together all the knowledge of his day, and greatly added thereto by his original observations and researches. He was original and talented, and his influence was felt for hundreds of years. It may be said to have dominated all thought until well into the Middle Ages. The first who dared question many of his findings and add original scientific researches of his own was Versales, who was born in Brussels and lived from 1514 to 1564. Versalius was a man of great force and originality, and fortunately had had good training under Sylvius, after whom the fissure of Sylvius is the fissure of Sylvius in the brain is named. That was a bit of a tongue twister. Versalius studied in Brussels and Louvain, and afterwards went to Paris and then to Padua. He was a great anatomist, and his work on the structure of the human body may be said to have laid the foundations of modern biology. The plates illustrating his work were a model of excellence. Naturally, great opposition to his work was encountered from the clergy, who tried to discredit his book. Versales, however, became court physician to Charles V of Spain, and afterwards of Philip II. His two scientific opponents were Fallopius, professor of anatomy, and Padilla and Estilius, professor of anatomy in Rome. Their opposition may be linked to that of several great men in Darwin's day, who steadily opposed his views on evolution. Pardon me. The next figure is that of William Harvey, 1578 to 1667, popularly known for his proof of the circulation of the blood. He was court physician to Charles I and wrote extensively upon embryology, physiology, etc. His treatise upon the circulation of the blood is a model of clear reasoning. It must be remembered that these earlier writers and experimentalists had to proceed without the aid of the microscope, since that instrument had not been imported into Europe yet. With its introduction and gradual perfection, great strides were at once rendered possible. Among the early microscopists were Robert Hooke, 1635 to 1703 in England, Swammerdam and Leeuwenhoek of Holland, and Malpigny of Italy. Of these, Malpigny was historically the most important. He taught in Bologna and Messina, devoting 40 years of an active life to anatomical research. He demonstrated the structure of the lungs, of the skin, demonstrated the nature of the papilla on the tongue, and carried on many researches to the nature of the glands. In addition to his anatomical researches, he wrote a monumental treatise on the structure and metamorphosis of the silkworm. He also wrote a classical treatise on the anatomy of plants and conducted many embryological investigations. The amount of original research he did was remarkable. Jan Swammerdam of Leiden was the first to describe the blood corpuscles. He discovered the value of the lymphatic vessels and made many other important contributions to anatomical science. Leeuwenhoek discovered a number of microscopes and used them in his investigations. He first saw the capillary circulation of the blood. While he accomplished an extraordinary amount of work, he did not leave behind him any one great treatise, such as that of his contemporaries. The importance of his work was only realized much later. Bonnet, also a Hollander, 1707 to 89, conducted a number of investigations of the minute anatomy of insects. The remarkable quality of his drawings is, perhaps, the outstanding feature of his work. Servinius, 1580 to 1656, wrote the first standard book upon comparative anatomy. It was published in 1645. The real founder of comparative anatomy, however, was Cuvier, Cuvier, 1769 to 1832. His classical work on this subject embraced both the vertebrates and invertebrates. He exercised a profound influence on scientific thought, but he also retarded the acceptance of evolution in the modern sense, owing to his opposition to the views of Lamarck. Milne Edwards and Richard Owen are important names which should be mentioned here, the latter being virtually succeeded by Huxley. Audubon, 1797 to 1841, was a French naturalist of distinction. Bichet, 1771 to 1801. Boy, he didn't live long. A Frenchman, and is generally recognized as one of the most influential biologists who ever lived. His industry was phenomenal. he published a treatise on the membranes, one on general anatomy, one on descriptive anatomy, and one upon life and death. He also wrote a number of papers and performed a great number of dissections. Buckle calls him the greatest man in his line since Aristotle. Wow. Schwann was the founder of the modern cell theory. Kolliker was one of the greatest histologists of the last century. Schulze is notable for his work upon protoplasm. Protoplasm? Rudolf Virchow of Berlin elaborated the cell theory and applied it to diseased conditions, his most noted contribution being his work on cellular pathology. Raymond Y. Cajal of Madrid is noted for his researches upon the nervous system. Retracting our steps now for some years and turning more especially to the rise of scientific physiology, we must mention as probably the greatest name after Harvey's that of Haller, 1708 to 1777. He was perhaps the first great physiologist. Strictly speaking, his work upon irritability is famous. His book, The Elements of Physiology, marks a distinct epoch in scientific progress. Charles Bell, 1774 to 1842, was the first to prove the nature of the pairs of sensory and motor nerves issuing from the spinal cord. He was a surgeon of eminence. Johannes Müller, 1801 to 1858, was one of the greatest physiologists of modern times. His Handbook of Physiology is still classical. Marking a distinct era in scientific progress, he was one of the first to bring out the close relationship between brain and mind, and correlate psychology and physiology. He was distinguished in physics, chemistry, and psychology, as well as in his chosen subject, physiology. Ludwig and Du Bois Raymond were both pupils of Müller and his worthy successors. Claude Bernard, 1813 to 1878, was a French biologist of extraordinary power. He proved that the vasomotor nervous control the caliber of the blood vessels and hence render possible blushing, blanching from fear, etc. He discovered the formulation of glycogen within the liver, perhaps his most important discovery. His work on the phenomena of life, published in 1878, is still famous for its breadth of learning and wide research. Friedrich Wolfe was one of the early scientific embryologists. He published in 1759 his book on the theory of generation, in which he combated the pre-formation theories in vogue in his day. He also published a work on the formation of the intestine, a very important contribution. What Johannes Müller was for physiology, von Bauer was for embryology. All subsequent growth was influenced by his investigations. Von Bauer, 1792 to 1876, devoted the later part of his life to researches in anthropology, but his fame chiefly rests upon his great work on the development of animals, undertaken during the first half of his life. His observations on the germ layers is that for which he is chiefly noted. He established comparative embryology and was probably the first to establish the general proof that embryos in development tend to reciprocate their ancestral history. That is recapitulate their ancestral history. Francis M. Balfour, 1851 to 1882, was perhaps one of the youngest men to achieve lasting fame in this field. In 1874, he published with Michael Foster The Elements of Embryology. Huxley considered him the most promising man of the day, and stated that he was the one man to carry on his Huxley's work. In 1880-81, he published his monumental treatise on comparative embryology in 2 volumes, which marks an epoch in this field. That same year, when only 31 years of age, he was killed, together with his guide, while climbing an alpine height in Switzerland. His untimely death deprived science of one of her most promising workers. Oskar Hertwig and Wilhelm Oskar Hertwig and Wilhelm His are 2 embryologists whose work should be noted, the latter's investigations of the origin of the nervous system being especially important. Bovary van Bendenden, Virchow, and Kalevsky are also noted names. Thomas Henry Huxley, 1825 to 95, may be regarded as a typical biologist who had helped to influence modern thought, both by reason of his own researches and his popularization of science for the masses, but also because he championed evolution, when that theory was first propounded and defended it against all attacks. Huxley styled himself Darwin's bulldog, and was the fighter while Darwin was the detached scientist, largely because of ill health. Huxley was a strong evolutionist, and he might well be placed in that list also. His Manual of Biology, published in 1874, was one of the first to emphasize practical laboratory teaching, and his 9 volumes of essays are models of clear thinking, rendered all the more valuable by reason of his clear and vigorous style. And I think we'll end there.